Okay, I'm back with the second video in this series on my Tig Welder controller. In this video, I'm going to show you my personal setup and talk a little bit more about its operation. I have my personal box here that's connected to my ESOB EMP 210 welder. And in the first video, I showed you what I'll call a base model of the box. And my personal box here has a couple of options that a lot of the models that I've been building don't have. The two options it has is a valve, a solenoid valve, which is right here, that controls the gas flow to the torch. And for welders that don't have a solenoid valve built in, this is a great feature. You'll notice that the outlet of the valve has this brass connector that the torch line connects to, and that's the fixture that comes with your gas regulator. And you simply remove that fixture from your gas regulator, and I'll show you a close-up. It's originally right here on your regulator, and you remove that and you install that on the outlet of this solenoid valve, and then your torch line connects to that. On the inlet of your valve, I have a push to connect fitting, and then tubing running from that to another push to connect fitting on the regulator that I installed in place of that brass fitting. The valve is wired into the box, and the circuit board within the box is equipped with a relay that controls the gas flow with pre and post flow control. The other feature that this unit has is a current sensor. Now, this current sensor that I used on my box works great, but it's a little bit clunky and the configuration is a little bit, I would say, expensive, probably needlessly so. It has two additional cables that connect to the sensor. It's a Hall effect sensor. And these cables are connected to the ground lead from the welder. So the outlet for the ground lead from the welder goes into the positive side of the sensor. And then there's another cable that connects to the lead itself, which then goes to the clamp and the workpiece. The reason why I say this a little bit clunky is even though it works great, I've built other boxes with pass-through Hall effect sensors that don't require these extra cables. It has a ring, a split ring, that you simply pass your workpiece ground lead through, and in my opinion, it's a much better setup. But this works fine, and I like it. And when you get that sensor, that current sensor, it enables you to have the adaptive start control, which uses the sensor to detect when the arc is struck. And at that point, the software transitions to the warm-up phase. And that adaptive start control also allows the box to initially set a very, very low start current, and assuming the sensor doesn't immediately detect an arc start, it ramps the current up until the sensor detects an arc start, and that avoids contamination of your tungsten and marring the material. It's a good feature. The other thing that you have with this current sensor is the ability to connect a Windows PC to this USB port, and then the unit streams via a serial interface. It streams information to the PC, and the PC records it in a CSV file, and then it's available for post-welding analysis. So those are the two optional features that the box has. And like in my first video, there are two cables coming out the back, one for the pedal and one for the welder. Now this has, and a lot of my personal boxes have these screw terminals on the cable. And again, they're not very robust, but I use those so I can transfer the box easily between welders that use different types of connectors. You can see a close-up here of the ESAB type of 8-pin circular connector, which my welder has, and I built these boxes with all kinds of different connectors for different welders. And so operation, it's very simple. Initially everything is turned off, and with the box hooked up and connected to the welder and the pedal, there's a picture of my pedal, by the way. You simply, first you turn on, and you start with the gas turned off at the regulator. The first thing you do is turn on the welder, and you can hear the welder spooling up. And then you set your base current. I was welding thin stainless steel, so I have a very low base current. I'm set at 55 amps right now. Once you do that, you press the power button and you turn on the box, and you wait for it to go through its startup routine in the main menu to be displayed. At this point, you can turn on the gas. You don't turn on the gas until you get the main menu, because part of the startup routine is it cycles the gas valve, and there's no sense in wasting gas. So at this point, you turn on your gas, turn it on all the way, and then you'd set your flow rate over here with your regulator. And then you would go through, as I demonstrated in the first video, setting all your configuration and parameters. Again, I was welding thin stainless steel, so I was set up with the 2-wire type for the ESAB welder. I'm not using the bypass. I'm not using the no pedal option. And with the current sensor, I do have the adaptive start enabled. And if you look at the parameters I've been using for this thin stainless on the pulsing parameters I've been using, a very low frequency. I'm pulsing at a half a hertz. For this particular job, I found that does a good job of freezing the puddle and then penetrating after you freeze it. Relatively low threshold of 35% and a duty cycle of 40%. But once you get your parameters set up, then it's just normal operation. The ground lead is connected to your workpiece, and you operate with the torch, and you operate with the pedal. For this job, and there's a picture of the stainless In this case, it's an exhaust cutout I'm making for my car. I just finished tacking it, so it isn't finished welded yet. But I'll let you hear that when you press the pedal, you can hear the gas turn on. Hopefully the microphone is picking that up. And then when you leave off the pedal, it'll continue to flow for a little while. And right there, it's shut off because the post-flow timer expired. So that's an overview of my personal setup. In my next video, I'll try to capture some video of an actual pulse weld session. Thank you very much.